What's going on, guys? Today we're going to be going over three algorithms: the reverse array in place, the Fibonacci, and also Fibonacci memoization. These are pretty simple algorithms, and that's why I stuck them into one single video. So stay tuned for that. So guys, we're going to be going over the reverse array algorithm first, and there's two types of question with this one. They typically ask reverse an array, which I'm not going to go over with, because when they're trying to solve it, what they typically do is they give you an array and they just tell you reverse this array. So what people typically do is make a temp array and start pushing the very last one, make a for loop of this array starting at the very last element and start pushing it into that array, right? And there you go, you have an array or reversed array. But the second problem they typically ask is reverse an array in place, meaning that using just this array, not creating another array, not creating a temp array, just using this one array, reverse the numbers within it. So this is a little bit, just a tad bit trickier. It's a tad bit trickier. I'm being serious. It's not that hard. So the thought process is we're gonna just get the length of this array, and we're gonna for loop. We're gonna do a for loop with the array length divided by 2. The reason why is because since we can only use this one array and not create another array, we need to swap out this first one with this last one and then continue on. If there was more like 4 or 5, we gotta swap out this one with this one with this one, and this 2 just stays the same. It wouldn't really matter, because even if it did, it'll just swap out 2 with 2. But you get what I'm trying to say, right? This is the way I'm thinking about doing it. Swapping out this one with this one, and then also this one with this one. So this is gonna be 5 and 0. This is gonna be 4 and 1, and then 2. This is the way I'm thinking. There's probably another way you could do it, but all right. Let's create a for loop. No, not that kind of for loop. With the array and length divided by 2. Divided by 2. All right. So let's take this first array. I'm gonna just delete some of these elements. So this array has 3 in total. Divided by 2 is 1.5. So you're gonna be left with 1. So when it comes to a for loop, it doesn't it floors it. So it's gonna be, if it's 1.5, it's going to be a 1. So you're gonna just iterate this one time, and you'll see it right here. I think it's only 1 time or 2 times. I'm not too sure actually. I think it floors it. We'll check it right here. We'll check it right here. So we're gonna just grab half of the array, and we're gonna assign. We need to get this first variable. So var. Oops, no, not there. Right here, var temp array or variable var is going to equal the very first one we're gonna get, or whatever the current for loop is at, which is at 0. So we're gonna get this first one right here, and now we're gonna switch this last one, or we're gonna switch this first one with the last one. So array of I, whatever it is going to equal array. We're gonna grab the last one, array.length, right, -1. This -1 is going to give us the very last one, which is right here, because remember, this array.length gives us the human way of counting. So 1, 2, 3. We don't start off at 0. We start off at 1, 2, 3, 4. So 1, 2, 3, right? But in machine counting, it actually starts off at 0. So 0, 1, 2. So that's why we have this -1, because right now it's going to return 4, which we don't have a 4th element up here. We need to get -1, where it's going to give us this 1 right here. And then we're going to subtract also the current for loop or iteration that we're in right now. And now we're going to swap this last one with the first one we just got. So I'm just copy this. And it's going to equal temp var. Return array. All right, and I'm actually going to figure out how many times this thing loops. So I'm gonna log out I'm gonna just say how many times looped. I'm gonna just say like that, even though I'm misspelled some things. Okay. So let's actually run this. I hope you understand what I'm trying to do. So let me explain one more time. Let me just do it with this one right now. So var I equals 0. We're gonna get half of the array length and then increment. This is pretty simple, right? So right now it's 1.5. I'm gonna say 1.5. I'm not too sure if it's 1 or actually 2 times. It doesn't really matter. I'll tell you why in a bit. So we get the first element in the array right here, whatever I is, which is 0. We get the first one. And then we're going to assign the first one, whatever I is, 0. We're going to assign this first one to the very last one right here, minus I, which is still 0, so it's going to be 2. So we're assigning this one to 2 now. Now this one is 2. Let me create another one right here. Now this one is 2, right? 2, 1, 2. And it's still like that, 2, 1, 2. Now we're going to assign the last one with the one we just got, which is 0. So we're changing this to 0. Boom. 2, 1, 0, which is a reverse array. Now let's say that it does do it to the second one, right? Like it does go up 2. So array.length is divided by 2 is 2. So now we go up 1. Now this is 1. So now temp var is 1. Array I, which is still 1, is going to equal array I minus 1, which is this very last one, minus 1, so it's now 1 again. So we just swapped out 1 with 1, and we're going to swap out the very last one with I, which is still this very one right here, with the temp var, which was 1 at the first place. So it doesn't matter if it's 1 or 2, but I'm going to actually figure out if it actually floors it or not. And I did not call it, that's why. So console.log, console.log reverse array in place, and we're going to just put in an array of 0, 1, 2, starting off just simple. How many times looped? It actually looped twice. It looped twice. Okay. Nice to know. It doesn't really matter because, like I said, it doesn't matter how many times it looped, 1 or 2, it still gets the same result. So 2, 1, 0. Now you know that if it's 1.5 or 1.3 or whatever, it's going to bump it up, round to the nearest number. I mean, bump it up 1. So 2. Let's actually put 1, 2, 3, 4, 5, 6, 7, 8. We should get 4 times. Let me see. 0 to 8, that's 9 times. What? I don't get it. So it's 9 times, but now it looped. Oh, it looped 5 times. Yeah. So yeah, it bumps it up 1. Okay, great. So 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, that's done. Moving on to the Fibonacci one. All right, Fibonacci function. Fib. I'm going to say fib. And basically with this question, position, pause. I'm going to say pause. Basically with this algorithm or problem, they're talking about like, give me the position of the Fibonacci, give me the position of 3 of the Fibonacci sequence. If you don't know what the Fibonacci sequence is, honestly, I don't know why people say this, but some people say that it starts off at like this: 1, 1, 2, 3, 5, 8, 13, and so forth, where the next number is the 1 the previous two added. So 1 and 1 is 2. This one is 2 and 1 is 3. So 3 and 2 is 5. 5 and 2 is 8. 8 and 5 is 13. 13 and 8, you get it, right? That's Fibonacci sequence, but it actually starts off at 0, 1, 1, 2, 3, 5, 8, 13. So I'm gonna do it this way because it literally starts off at 0. So I'm gonna do it at 0, but people do it at 1. You just gotta make sure how they interpret Fibonacci code, even though the correct way is starting off at 0. So let's figure this out. So we do need a base case, okay? Actually, let's simplify this and just make it 1, 1, how people typically use it. I don't know why. But let's start off like this at first. So we need a base case, meaning that what's let me show you right now. If pause is less than 3, return 1. This is considered the base case. Why is it considered the base case? That's because that if we want to know the position of 0, if we want to know the position of 1, which is this, or 2, which is this, we're going to have 1 and 1. So we're going to just return a 1. It doesn't really matter. We don't need to figure out if it's position 3, we don't need to figure out what position 1 and position 2 is to add them together to get position 3. We don't need to figure that out. We just know that it's 1, 1, right? So that's why I say if position is less than 3, is less than right here, this position, which is these two, is going to return a 1. And we're going to be using recursion for this. A lot of people use recursion for this, even though there's a lot of ways to not use recursion. But we're going to be using recursion because that's what, if I'm not mistaken, the interviewer asked for recursion, how to do it recursion. So else we're going to just return the recursion of this Fibonacci. So fib of the position pause minus 1, and don't worry, I will tell you what's going on. And then fib again, we're going to call the same. Recursion is calling the function over again. That's all it is. Position pause minus 2. And this is it. This is literally it. Control save. All right. So the Fibonacci, what's happening right here in this recursion? Well, let's say we do want a position 3 right here, which is 2. We pass in 2 or 3. It's going to go to the else statement, right? So position 3 minus 1, which is going to be this one right here. And then plus fib position minus 2. 3 minus 2, which is this one right here. And it's going to add 1 and 1, which is 2. And it's going to return 2. The reason why we call it recursion is because let's say we go to position 8. We want to know what position 1, 2, 3, 4, 5, 6. We want to know what position 6 is, which is 8. It doesn't know, and this interpretation of this algorithm, it doesn't know what position 5, 4, 3, 2, 1 is. It doesn't know what that is. Okay. So what this is going to do is going to say, okay, I want position 6 right here, minus 1, which is 5. Okay, hold on. It's going to stop right here. It's like, I don't know what this is. So let me actually go one more down, which is position minus 1, which is 7 or 6, right? Or with 5, sorry, 5. So position was 6. I need to put it right here. 6. Position was a 6. Position 6 minus 1 is 5 right here. 1, 2, 3, 4, 5. Yeah, 5. He's like, okay, I don't know what position 5 is. So I'm going to just go to position 5. Now this is a 5. Now let me see if I have the position minus 1 below that. So it goes right here, position 5 minus 1, which is 4 right here. I don't know what that is. It's going to keep on going down until it goes all the way to the beginning and say, okay, I know what position 1 is, which is 1, because we have it right here. I know what position 2 is because we do have it right here. So now it's going to start incrementing, going up one by one until it gets right here, starting adding all these numbers, and it's going to give you 8 finally. Control save, and let's actually console log this. .log Fib 6. Control save, and let's run it now. It should give you 8, yes, and it does give you 8. If we do 7, which it should give you 13, 7, 13. All right, but the problem with this is that every time we want to know another position like 13, it still has to go all the way down here and start from the bottom and start its way up again. If we wanted to know what 8 is, even though we've already know what 13 is, like it passed through 8, right? It passed through these numbers, even though we went to 13. But if we go right here again and say, I want Fibonacci of position 6, which is this one, it still needs to go all the way down to the beginning and start doing it again until it gets here. So it doesn't matter where you start at. It's going to always start at the very beginning and go up from there. And this is the problem. This is why recursion, it sucks. If you could avoid using recursion, avoid it. I mean, there are some cases where you do need to use recursion and it's better suited for it. But for this example, let me pass in 500, for example. Control save. We want to know the Fibonacci position of 500. See, I just pressed enter. Now it's stalling. It's like this is too much. I can't handle it. I'm actually going to Control C before it freezes my computer. It does freeze your computers sometimes. Sometimes it will freeze your computer. It's too much to process, guys. And the recruiter is going to say, is there a better way to solve this? And there is. The way to solve this is by using a hash table that actually saves what the previous numbers were. So if you want to know position 6 right here, it will know position 5 and position 4. Because it already knows these things, right? If we wanted to know position 13, since it's been through all this already, it's going to know what position 6 and position 5 is. It'll just add those together and spit out 13. This one, it doesn't add anything. It doesn't know anything. It just starts at 0 always and starts working its way up. This next algorithm, the one we're going to be doing, does know what it's talking about, does know the positions before it, and gives you a faster answer. So let's actually write it out. Function fib memoization. It's called memoization, Fibonacci memoization. And this time we're going to add in the position that we want and also the hash table that we're going to be storing in. And we're going to be just calling that, I guess, cache, right? Because we're caching everything. All right. So, cache for right now is going to equal, if cache does have anything, we're going to make it equal that, or it's going to equal an empty array. Okay? And don't worry, we are going to get into it a bit later on. If cache in position, we're going to return cache position. This is basically saying that if we have the position in the array, which let's say that we wanted position 5, and we have this array right here, then we're going to just spit out whatever the position is at 5, which is 5. Else, if it doesn't know what it is, then we literally have to go through this thing again up here. So I'm just grab this right here, copy this, paste it right here, because we do have to go through this again. So else, if position is less than 3, return 1. Obviously, we've been through this already. Return, and we're gonna just, instead of having to return this right here, we're gonna actually save it in the cache, right? So cache index or position is going to equal Fibonacci whatever, or let me Fibonacci memo now. Fib memo position -1, and we're still entering the cache. And position 2, cache. And we're going to return right here. Return cache. And I will explain in a better way, I know, of position. Now I'm going to just grab this, copy this, and paste it down here because we're going to be doing I want position 7, which is 13. Okay, let me explain what's going on right now. You already know what Fibonacci is, right? And this one doesn't store anything. Right now, we're going to be storing everything that we've been solving. So right now, since it doesn't know anything, it's learning. Let's say we wanted position 3. It doesn't know what it is, so it's going to say, okay, position 1 is going to be 1. Position 2 is going to be 1. Position 3 is going to be position 1 plus 2, which is 3, right? So it actually stores this in an array where this array is now 1, 1, 2, which is right here. Now let's say we want position 3 or 4, right? It's going to look at the array. That's why we have this right here. It's going to look in the array. Do we have position 4 in the array? No, we don't. So we're going to just, right here, we're going to have it right here, and we're going to just put in Fibonacci memo. Remember, this is the same thing. We're going to say position now 4, position -1, which is 3, and cache. We're putting in right here now. 3 and 1, 3 in the cache, which is 1, 1, 2. Does the cache have position 3? Yes, it does. It's 2. And it also has 1, so it's going to just add these together and just spit out 3. It didn't have to go to the very beginning. It just added the last 2, since it already knew what it was. So this algorithm just stores in the last, or it stores in every Fibonacci sequence until it doesn't know. You know what I'm trying to say? I don't even know what I'm trying to say. It just stores in the number while it's going. So let me see. Let me try to run, let me actually save this, Control Save. And we're going to run it again. Oops, count the log. Fib memo, not fib. Control save. It's going to give us 13. Now let's do 500. Now remember, this one didn't know, this Fibonacci didn't know if it was 500 or not. But this one, you'll see. Oh, look at this. It actually gave us a number back. The reason why it gave us a number back is because it's not having to go all the way to the very beginning and it starts to go all the way to 500, position 500. This one starts at the beginning. Yes, it does start at it actually starts at position 7 because remember, we did position 7 first. It starts at position 7 and starts going on from there, starting adding the numbers again. So it's just referencing the very last number that it got and keeps on going from there. While this one doesn't reference the last number, it references from the very beginning, which is going to take forever. Anyways, guys, I hope I actually taught you something. I'm not too sure about this one. I'm not too sure. It was actually, honestly, guys, I'm not that good with recursion whatsoever. I really ain't. So talking about this right here, it's kind of hard for me, but I hope you actually got something from this video. So please consider subscribing, comment, and like the video. And thanks for watching, guys. I really do appreciate you guys watching my videos. And stay tuned for the next video. Thanks. Bye.